All right, hello everyone. We are here to go over the application of square roots and square numbers, and then as well as the cube numbers and cube roots homework that was sent home to you today. So we're looking at square roots. It says a positive square root is called the principal square root, and it is represented by a radical sign. That is called a radical sign. So if we want to simplify square roots, we're just going to be thinking, okay, what two things multiplied together are going to give me these things? So we kind of have two elements going on here. We have a 9 that can be broken down, and then we have an x squared. So I like to make these things called multiplication trees. These help me determine what two numbers can I multiply together to get 9. And you always want to do pairs, so the same number just multiplied twice. So I'm thinking 3 times 3 will give me 9. Notice how they are the same number. I always want to have the same number multiplied together to get that number. So 3 would be that. For the x squared, I know that x times x is going to give me x squared. Okay, for square roots, we're going to take one and leave everything else. Take one of those pairs and leave everything else. And what we have left, we will multiply together to get our answer. Okay? Same thing here. Even though it's a fraction, we can figure out what two numbers multiplied together can give me 25 and can give me 4. So I'm thinking, what number times itself can get 25? So two numbers that are the same multiplied. That would be 5 times 5 gives me 25. And 2 times 2 gives me 4. So take one, leave one, take one, leave one. We always want to take one out of those pairs. Okay, so then we're going to take our 5, put it on the top of our fraction, and the 2, put it on the bottom. We no longer need the square root sign, the radical sign, because we have now found the square root. So that is our answer. The steps here were to take the square root of the perfect square out. And just a note here, a variable squared always comes out alone. So x squared, when you square root it, it'll just come out by itself as x. Okay. Here we have kind of some information. All positive real numbers have two square roots. It can have a positive or a negative square root. To indicate the positive and the negative square root of a number, we put the plus minus sign in front of the radical. That basically means that when you have something like this, some number squared equals 25, you could potentially have 5 squared equals 25. You could also have negative 5 squared. So we do not know if it's actually a positive or a negative 5. So in our answer, we just want to give the possibility and just kind of show, the answer could be positive or negative. And we recognize that. And so we show that by just doing the plus minus sign. Okay. To get rid of an exponent of 2, all we need to do is square root. And if I square root one side, I have to square root the other. Now I'm thinking, what two things multiplied together give me x squared? Well, that's going to be x times x. What two things that are the same number multiplied together give me 25? Well, that will be 5 and 5. Now I just do my process of take one, leave one, and I figure out that x equals 5. Okay, to undo the exponent, solve by taking the square root. Same thing here. To undo this exponent, I take the square root. So what two things give me x squared? Well, that will be x and x. To give me 4, it'll be 2 times 2. And to give me 9, it'll be 3 times 3. Take one, leave one. I get x equals, leave it in a fraction, 2/3. Okay, to undo the exponent, solve by taking the square root of both sides. Okay, and last one for this side. Okay, imagine if this was just 2x equals 18. To solve that, we would divide by that coefficient, and it's going to be no different when there's an exponent. So the first thing we want to do is divide everything by 2 to get that coefficient away. So we're going to divide the coefficient by 2 on both sides. Okay, so divide by 2, you'll get x squared. It's still there. We haven't dealt with the exponent, equals 9. Okay, to undo an exponent, you take the square root. Okay, and I'm thinking, okay, x times x is x squared, and 3 times 3 is 9. Take 1, leave 1. X will equal 3. Solve by taking the square root of both sides. Okay, looking at the back side, we're dealing with cube roots now. That is just something multiplied 3 times. Okay, so when it says x equals 2, we'll just replace x with 2. So this will be 5 times 2 cubed. 2 cubed is 8, so 5 times 8. 5 times 8 equals 40. Okay, when y equals 4, it'll be 2 times 4 cubed. 4 cubed is 64, and 2 times 64 is 128. Okay, same thing here. We're going to find the cube root of these things. There's kind of 2 elements of things we can find cube roots for. We can look at 125, and then we can look at x cubed. So what number 3 times itself gives me 125? Well, I know that is 5 times 5 times 5 will give me 125. And to get x cubed, I know that's x times x times x. Now for cube roots, you take one and you leave everything else. You only ever take one of those pairs. Okay, put those 2 things together and the solution will be 5x. So take the cube root of the perfect cube and a variable cubed comes out alone. Same thing here, we have kind of 2 elements we can cube here. So we have 27 and we have 64. So I know that 3 times 3 times 3 will give me 27. And you can actually look in your notes for this. And 4 times 4 times 4 will give me 64. Take one and leave everything else of all of those kind of trios. Keep it in a fraction, and we no longer need the square root because we have found, the cube root, we have found it, so we don't need that radical sign anymore. The answer is just 3/4. All right, let me go turn on my lights. Okay, last portion here, we are solving, so I know to undo the exponent, solve by taking the cube root of both sides. So I'm going to cube root this side and cube root this side. Okay, I know that to get x cubed, you would have to multiply x times x times x. And I'm actually going to look back at my notes to find, okay, how would I get 216? It's actually in our notes, so let me look through our notes that we did so I can show you where to be looking right here. So it looks like 6 cubed is 216. So that means 6 times 6 times 6. Take one, leave the others. Take one, leave the others. That means that x equals, and remember, it could be, actually it's just 6. Sorry for that. My brain is confused. Okay, very last one. Remember, we always get rid of the coefficient first, so divide the coefficient by 4 on both sides. So divide by 4. You'll get x cubed equals 27. And then solve by taking the cube root of both sides. So cube root. Okay, I know that x cubed is made up of x times x times x, and 27 cubed is 3 times 3 times 3. Take one, leave the others. X will equal 3. Right, and there was your homework.